Welcome to the first session of the training and introduction to working with the 555 IC. In a series of sessions related to the 555 IC, along with giving a brief explanation about the 555 IC, I'll also put together a small project for you so that in this way we can get more familiar with the 555 IC and how it works. We generally know the 555 IC as the 555 timer IC, and because of the tasks it performs in generating square wave signals, time delays, and similar applications, it's called a timer. But its functions go beyond that, and it's used in both analog and digital timers, and even helps us with things like impact and touch detection, along with many other applications. The 555 IC is one of the most well-known and widely used ICs in electronics, which was introduced by the company Signetics in 1971. Generally, people sometimes refer to the 555 IC as the 555 circuit. Basically, if we were to open up an IC, there's a circuit inside it, so we no longer need to put several transistors, resistors, and such together on a breadboard or our own board to get the output. All of those components have been brought together in a small box and given to us as an IC, which actually stands for integrated circuit, meaning a circuit that is integrated. They put several circuits together so that we get the output we want. The 555 IC circuit, as you can see here, has several pins, or what we call terminals, each of which has its own function. By connecting them to each other or to other components, we can achieve the desired output. Now, what does each of these pins do? In this session, I'll just give a brief overview of the pins so we can quickly move on to building our first project. To see the correct way to identify the pins, you should hold the 555 IC so that this notch here is facing up and the pin numbering starts from the left. That means this first pin is number 1, then 2, 3, 4, and from here this is 5, 6, 7, and 8. Each of these pins has its own function. Now, what do they do? To help you understand better, I'll put the schematic of this IC here so that based on that, you can more easily grasp what each of these pins does. Well, according to this schematic here, pin 1 is the power supply pin or ground or GND, meaning if we connect it to our power source, then the negative terminal of the power supply should be connected to pin number 1. Pin number 2, or the control pin or trigger, is used to activate the IC. Pin number 3 is the output pin of the IC. Pin number 4 is the reset pin or the pin for restarting the IC. Pin number 5 is used to control the output voltage level. Pin number 6 of the integrated circuit is the threshold pin. And pin number 7 is referred to as the discharge pin, which is specifically used for discharging the external timing capacitor. Pin number 8 is the positive supply pin. That means if we are connecting the IC to a power source or a battery, the positive terminal of the battery or power source should be connected to pin number 8. All right, up to this point, let's go ahead and build our first circuit together, which is a simple LED flasher circuit. This will be our first project using this IC and will serve as the foundation for other circuits. Let's get started together and see what components we need. So for this circuit we're using, it's an LED flasher circuit, and of course we have a 555 IC, which I've placed on the breadboard like this. And the prerequisite for this series of ICs is that you already know what electronics is and are familiar with the components. So I don't see the need to explain what each component is, what it does, or where it should be placed, because you already have this familiarity and know the basics of electronics. And if you want to start along with me, you can watch these tutorials, that is, these tutorials related to ICs. If you have any questions about the components, go to the basic electronics course or the beginner electronics course and watch those sections alongside this one so you can progress through all of this in parallel. All right, we need an IC here and we have a breadboard as well. I also need to have an LED here and a capacitor. I need a capacitor here, and for the LED that we want to blink here, try to use a 10 microfarad capacitor at most, but the smaller the value, the better. Why? Because it makes our circuit work better. So here I have a 2.2 microfarad capacitor. Basically, this is the smallest capacitor I had available here. Now, if you have a 1 microfarad capacitor, that's even better. All right, so that's it for the capacitor. The resistor I'm using here is a 100 kilo ohm resistor. Look, a 100 kilo ohm resistor, and its color bands are brown, black, yellow, and gold. I'm going to use these, and I also have a few jumper wires here that I want to use to connect them together. I also have a power supply, and for this circuit, ideally you should use 5 volts. Basically, this circuit or this IC can operate between 5 to 15 volts, but for this purpose, 5 volts is suitable. You can, for example, use a 9-volt battery, or you can use these battery boxes and put several together, at least 4.5 volts or 5, but 5 volts is more suitable. Place the batteries together like this, or if you have a power supply, even better, set it to 4.8 volts or close to 5 so that we can get the output we want. So this is one of the components we need here. Let's go ahead and assemble them together and see what the output looks like.